Let's explore this hypothesis testing problem. The average height of an NBA player is 6.698 feet. A random sample of 34 players' heights from a major college basketball program found that the mean height was 6.75 feet, and remember, mean is one of the averages we would use, with a standard deviation of 4.9 inches. At alpha equals 0.05 or 5%, is there sufficient evidence to conclude that the mean height differs from 6.698 feet? Okay, now in case you forgot what alpha stands for, alpha is the significant level in a hypothesis test, or it's the acceptable probability of a type 1 error. In other words, it's the probability you can live with, and 1 minus alpha gives you the confidence level. Okay, so the first thing we should do is state the hypothesis and identify the claim. The null hypothesis, given by h sub 0, is the statement that there's no difference between a parameter and the specific value. So we would write that as h sub 0 colon, and then we use the average symbol equals 6.698. Now I called this symbol the average symbol, but technically we call that mu. It's pronounced mu, and it stands for the mean of a population. Okay, so let's move on to step 2. The alternative hypothesis, h sub 1, is the statement that there is a difference between a parameter and a specific value. In this case, the mean height of players from a major college basketball program differs 6.698 feet. And this would be equivalent to what you see right here, where you see h sub 1 colon mu does not equal 6.698 feet. Okay, so we move on to step 3. In step 3, we realize the problem asks, is the mean height of players from a major college basketball program different from 6.698 feet? And that means the claim is really the alternative hypothesis. So we move on to step 4, where we have to find the critical value. And from the figure below, you can see for a two-tailed test with alpha set at 5%, the critical value is 1.96. Next, we have to compute the test value. We're going to use the z-test, which is a statistical test for the mean of a population. It can be used either when n is greater than 30, where n is the sample size, or when the population is normally distributed and has a population standard deviation that's known. So the formula for the z-test is given right here, and you've got all the variables listed. So we take z is equal to the sample mean minus the hypothesized population mean divided by the population standard deviation, which is divided by the square root of the sample size. Now, since the sample standard deviation has been given in inches, we should convert it to feet. So we'll use S in place of the population standard deviation to calculate the test value. Right? So sample instead of the population. So we'll take the 4.9 and convert it to feet by dividing it by 12, and we get 0.408 feet. Okay, now I've changed the focus so you can read the bottom half of this image. And then we use the formula for the z-test. We plug in the numbers that we have, and we calculate 0.74. So the test value rounded to two decimal places would be z equals 0.74. Okay, at step 6 we can now make the decision. And we're able to look at the critical value of 1.96, and we see that 0.7 fall doesn't fall in the critical region. Since it doesn't fall in the critical region, we would not reject the null hypothesis. And finally, we get to the last step where we summarize the results. Since the null hypothesis was not rejected, there's not enough evidence to support the claim that the mean height of a player from the major college basketball program differs from 6.698 feet.